we are discussing time of flight. What is the meaning of time of flight? We will be finding time of flight for various examples of a particle thrown under the gravity following different path. So the first question that arises in our front is, what is time of flight? How it can be defined? So to answer about that fact called time of flight, we can consider a very simple example. Say a particle is thrown from ground at an angle theta with the horizontal. As gravity always acts perpendicular to the surface of earth, or we can say vertically downward, so under this gravitational acceleration, particle will follow a parabolic path, maybe of this shape. Now for the said situation, we can say that object which has been thrown from ground, it remains in air along its path up to the time when it again hits the ground. So time of flight basically means time taken by the projectile till it is flying in air or in space. So what we have to do, we have to find the value of time of flight. Here it can be easily written that now we choose a reference frame XY coordinate system because this motion happens in two-dimensional platform because it is thrown from the ground, and this particle which has been thrown, it remains in XY plane and in entire its journey. So we have chosen a reference frame is XY coordinate system in which X is along the ground from where this ball is thrown till it again returns on ground, and Y axis is taken along the vertical direction. We know that acceleration of the particle is towards negative Y direction. So if we want to mention its acceleration in vector form, then we will give it to be vector A equal to minus G j cap. If velocity of the projectile is taken, then it can also be represented in vector form as vector u equal to u cos theta I cap plus u sin theta j cap. Now we can get time spent by this projectile in air in two different ways, either by using first equation of kinematics or by using second equation of kinematics. So from here till getting time of flight for this condition, I will follow two different paths. Just consider in the first method, we are using time of flight is 2 times of the time taken to achieve maximum height by this projectile, means this th time is the time in which this particle reaches from here its maximum height position. As we know, acceleration is uniform, so time taken to achieve its maximum height will be equal to the time taken by the projectile to descend the same height. Means when it reaches at the ground again, it takes the same time in which it has achieved that maximum height. So time of flight can be taken as 2 times of time taken to reach at maximum height. Now in the second method, we will use time of flight as using time of flight as the time in which its y component of displacement becomes 0. So what will we give? We give that time of flight is the time in which delta y becomes 0. So method 2 involves using time of flight as the time in which projectile's y component of displacement again becomes 0, because at the time of throwing this projectile it was at ground, and after one time of flight it again hits the ground, so y component of its displacement becomes 0. So we will just find time in which y displacement becomes 0, and that will be our time of flight. Now we are finding the numerical values of time of flight. In the previous case, which was the simplest case of projectile motion. So I am giving just the proof for time of flight here. So I am getting time of flight by the method number 1, which we have discussed on the previous page. So we know, for given condition, initial velocity of the projectile is u cos theta I cap plus u sin theta j cap. Acceleration, which we had written on the previous page, is to be minus g j cap, where g is the acceleration due to gravity. Now, the equation which we will follow, v equal to vector u plus vector a into time. If we use above values in this equation, then we get v equal to u cos theta I cap plus u sin theta j cap minus g j cap into t. We can simplify this equation to be equal to u cos theta I cap plus u sin theta minus gt j cap. Now, the twist comes from here. We can simplify it using a particular point, which can be explained as x component of instantaneous velocity of particle is u cos theta, which is time independent, means during complete motion its horizontal velocity remains same. But on the second component, which is along the y direction, so we call it component of velocity along y direction. For maximum height, y component of velocity becomes 0. Just think on this point, why I am saying this. We can write u sin theta minus gt, basically the y component of velocity, to be equal to 0. Here t can be taken as th, time taken to reach at the maximum height. So we get time taken to achieve its maximum height equal to u sin theta divided by g. As we have earlier discussed, that time of flight of the projectile in this case is 2 times time taken to ascend its maximum height. So it becomes 2 times u sin theta divided by g, which is our desired answer. So students, this is the time of flight for this case. Now, we will proceed to get this result by the second method also. So please go through it, because it will give you an advantage in your application part. Now, as we have discussed, in the second method, the informations of initial velocity and acceleration are same as on previous page. So I am writing it u cos theta I cap plus u sin theta j cap, and acceleration a to b minus g j cap directly. Now the equation which I have to use here is displacement of the particle to be initial velocity vector into time t plus half acceleration vector into time square. Here the values are as shown above. So I am writing the values of u and a in this equation. So it becomes u cos theta I k plus u sin theta j cap multiplied by time t plus half the acceleration is minus g j cap into t square. Here this displacement s is here obtained in I cap and j cap form. So obviously this displacement will consist of a x displacement and a y displacement. So I am taking this as h x I cap plus y j cap. So x I k plus y j cap, it becomes equal to u cos theta into t I cap plus u sin theta t minus half gt square j cap. Now is for t equal to time of flight, y displacement becomes 0. So u sin theta t minus half gt square is equal to 0. So we can write here u sin theta into time is equal to time of flight, so capital T minus half g capital T square, it has to be 0. Solving this equation, we get time of flight t to be equal to 2u sin theta divided by g. So students, these are the two different processes by which we got the time of flight. But especially I am stating that time of flight of a projectile depends on some facts like from where this ball has been thrown and at what position its motion finally stops or restricted by any means. Say a ball is thrown from ground to ground, then we have find the time of flight to be 2u sin theta by g. But if this projectile was interrupted somewhere at the height h above the ground by means of capturing it while sitting on a branch of tree. So if you capture this ball, then ball does not reach at the ground, and in this condition time of flight will be just the time from where its motion starts and the time at which its motion ceases. So here time of flight will be some other value. So depending upon the conditions, time of flight for the same thrown projectile may be different.